Hello and welcome to our latest video. In this video, we will discuss how to quickly interpret the results of an AutoML module. In Makya, the proprietary auto machine learning module, known as the AutoML, utilizes a continuous logistic regression model to provide the best model parameters and molecular representations, such as fingerprint size and radius, for a given target. The continuous logistic regression model has the benefits of a classification model, without the drawbacks, namely the threshold effect, and is supported by a Bayesian optimization in order to arrive at an optimal solution for each target in a reasonable time, and at a reasonable cost. Let's begin by reviewing the performance of an AutoML model that has already been trained. Once in Makya, navigate to the AutoML panel and select See Results to view the performance metrics for the model on each of the tested targets. These metrics have been computed on molecules belonging to a test set that has been randomly selected and has not been seen by the model during parameter optimization. The review and validation of a trained model is a critical step prior to the use in any future generations, as incorporation of a bad model will add noise to the system. Notice multiple performance metrics are displayed within the Metrics tab. To display details of a given metric or graph, hover over the question mark and click with the cursor. While a variety of metrics are available, this video's focus will be on how to quickly interpret the receiver operating characteristic, or ROC curve, and the precision or recall graphs. The first graph, located in the top left corner of the page, displays an ROC curve, plotting false positive rates and true positive rates at various threshold settings. When beginning to analyze the ROC curve, first take note of the slope of the curve. If the line were to pass through the point 0.1 in the top left corner of the graph, the model is a perfect classifier. Therefore, a steep slope at the beginning of the ROC curve means the rate of true positives is high, while false positives are low. This is indicative of excellent performance of a model. The next metric to consider is the AUC, or area under the curve. The AUC measures the ability of a model to distinguish between classes in a single value, and is a simple way to compare the performance of different models. The greater the value for the AUC, the better a model is at classifying data points between positive and negative classes. When an AUC equals 1, a model perfectly distinguishes points between two classes. When an AUC equals 0, a model will always make the incorrect prediction. While an AUC of 0.5 either predicts a class at random or a constant class for all data points. We recommend discarding models that have an AUC of less than 0.7. This is a general rule, and models built with fewer than 150 data points may require a more strict threshold. Precision and recall are calculated based on the confusion matrix located in the bottom right-hand corner of the page. Precision is a measure of the number of positive predictions that were made correctly. Recall, also known as sensitivity, is the measure of how many positive cases were correctly predicted within the total number of positive cases in the dataset. These are visualized in the graphs labeled precision/recall versus threshold, located in the top right-hand corner of the page, and precision versus recall, located in the bottom left-hand corner. These curves provide insight into what threshold maintains a good trade-off of precision and recall. Let's consider a real-world example to illustrate this trade-off between precision and recall. If you were to throw a net into a lake to catch fish, you may catch 7 of the 10 fish in the lake. This represents 70% recall. But within that net, you also capture 7 rocks. This represents 50% precision, as half of the net's contents are undesirable. However, if you were to throw a smaller net in an area of the lake more densely populated with fish, you may catch 3 out of 10 fish, but capture no rocks. This represents a 30% recall but 100% precision. The precision recall curve, located in the bottom left-hand corner of the page, provides a graphical representation of classifier performance and is tailored for the detection of rare events. A perfect classifier will pass through the point 11 in the top right corner of the graph. while a good classifier will maintain a high precision without degrading recall. This is indicated graphically by a horizontal initial slope that is approaching zero. The AUCPR represents the area under the precision recall curve and summarizes the graphical information in a single value. This metric is often preferred over AUC when classes of initial data are imbalanced, or when a positive class is of more interest than the negative one. A perfect classifier displays an AUCPR equal to 1, whereas a non-informative classifier will correspond to the rate of positive values in the initial dataset. Thank you for watching this video. If you have any questions regarding Makya, please reach out. We'll be happy to help.